Hi, my name's Carl. So this is video number 6, I think it is. So in my endeavor to find the parameters for the motor, it's led me down various paths. Initially, I thought that I could measure the rise of the pulse on the if I injected a DC voltage in there, I could measure the rise of the current pulse, which I can measure it. And then I sort of developed a filter to filter out the noise, because it was an extremely noisy signal, which I did. And then I sort of confirmed this via the rate of change, and I sort of worked out RS, and then from there I worked out LS, the rotor resistance, and the stator inductance. And that was okay for a period of time. I actually thought I cracked it, but the problem with the whole thing is essentially, like I said before, it's noise, and it does work. So you can measure LS there, or what I think is LS anyway. Let's put it that way, because I haven't got any test equipment for me yet. So you can do it like this. You pulse it and you measure this rise over here, and you measure a point on that, and you sort of calculate LS. Then you can sort of confirm this by performing various you basically differentiate the rate of rise. So you calculate the slope of rise, and you can sort of confirm LS. And then I done another test where you actually pulse the input, train a pulse like this, pulse it, and then you measure the current being generated. That current will be sort of a version of the magnetizing current. You can work out the magnetizing current from that, and you can also then work out LS. So that I done, and so I sort of had 3 tests. I call it 2.5, 3 tests, and this test. So I spent quite a bit of time doing this, and yeah, it worked. But then I see that the noise on the ADD has come back, and I got my wires a little bit sort of touching each other on the board over here. So one of the ATD wires was touching the motor, or the motor feed wires, and that was causing noise, and that sort of indicated to me that the filter, this EWMA filter, is not dynamic enough. Basically, it's good, if the system is more or less stable, but this is not the real world. So the filter needs to be a little bit more sophisticated than that, and or like I said before, root cause is actually a hardware filter. That's what I need to correct. But in order to move this thing on, basically, I've tried to sort of move away from changing the hardware. So I've picked on software, because you can manipulate software easier. So yeah, it's yeah, I'm not. I've sort of saying no to that test. It's there, but I say no. Then I looked at this test over here, pulsing, and this seems to be okay. And strangely enough, but it's very sensitive. This is a very sensitive test, So you pulse it at 50 hertz, and then you can measure various things. I mean, I can show you over here. So here's the software I done. So this is online at the moment, and so I can run it around, and bits in yellow are sort of the values. So it takes a little. It takes about, I think it's 20 seconds or something like that. So essentially, you just pulse 2 terminals, and then you have to compensate for the type of connection, star, delta, whatever, and then you get a result on that. So it takes, like I said, it takes a little bit of a time to do that. It should be about it now. So you can see the previous value. So stator resistance is more or less spot on all the time. It's 40, 49, 49. There it is, 49 point. There's a rotor resistance, which is 17, which is, yeah, okay, that can, yeah, surprise, surprise, on smaller motors, rotor resistance is high, and that ratio between the stator resistance and the rotor resistance, what I see on documentation, could actually be okay as well. And the rotor current is there, and there's the stator inductance. Now I'm still not sort of particularly overjoyed at that value of that stator. inductance. I'm not sure if that's too high. Yeah, I get a sneaky suspicion it might be too high. I can confirm something there, you know. But nevertheless, that this test seems to be more or less consistent now. So now I have consistency, more or less. So it's 2.62. Let's see what it does now. And I can improve the test. You know, I can pulse it at various different frequencies and then work out something there. So it's more or less there, I think. You know, this probably give me some obscure value now because I said it's more or less okay. The joys of developing software and hardware is yeah, it can be challenging, I must admit. So it's still running through the test now, and yeah, 2.5. So you see, it's not so like I said, so it's more or less consistent there. I mean, that is pretty spot on, and so now I can get the rotor resistance. So if we come back to my little squiggly drawing over here, I must admit it's not the best drawings, but anyway. So now that I can get this guy over here, the rotor resistance, okay, we sort of away. So we have everything, you know, in this more or less we have everything. There are some leaps of faith here, you know, but we can glean a lot of the data off the nameplate, so we can make references to NEMA standards, you know. So for the ratio of this leakage over here compared to this leakage, we can make reference to that. The percentage of that to the magnetizing inductance, well, that's, you know, we reckon that's about 98%, so that we need to work on maybe a little bit more. But I think I have enough here to move this whole thing up to the next sort of level, you know. So now that we've got that, I mean, so here's my software over here, so you can see I did write an FOC algorithm over here. So you know, if you're familiar with FOC, you can see sort of Clark, Park, and there's various things in here basically. So this is all the software here, basically from here to here that I've written. So that's there. So we just have to move it on to the next step now. Unfortunately, so we're coming up to the end of the year. It looks like we've gone into a lockdown in the area, tier 3 lockdown. So yeah, okay, wonderful. And also, this probably be the last video for this year on this. The next level up is to, I say this loosely, is probably to develop the motor control algorithm now that we can get some parameters out there. And also the hardware is now falling a little bit behind for where I want it. So although I have this big fancy board and all the rest of it, you know, obviously this is not a viable solution, you know, to make this, you know, monetary wise it doesn't make sense. You know, when you've got a board here that costs almost, I don't know, £1,000, whatever it is, and you can buy an entire inverter for you know, whatever, 200, £100 on the size, you know, probably less on this size. So that doesn't make sense. So that needs to be refined as well. But it's okay for development work. It seems to be okay. Although I probably need to develop a little bit more hardware on it. Like I said, the A to D converter. But I don't want to do too much on it because ultimately this hardware is just for the development work. And although I didn't want to get bogged down too much in development work, I mean, this bogged me down trying to get these motor parameters is proved to be quite a challenge. I must admit, you know, to get these motor parameters because, you know, it's not, you know, it's not as easily available as sort of working out the algorithm for the motor control. Surprisingly, you know, the information is not so freely available because it essentially, in the end, it actually boiled down to being something quite simple. In the end, I mean, it's just essentially just boiled down to it just boiled down to this little bit over here, this function over here. Okay, and it's not like a hell of a mathematical function, you know. There is some maths in there, you know. You sort of have to understand this maths how we get there. But I think that commercial motors I think use the same algorithm, because when I've tuned motors, it makes the same noise. Let's put it that way. The motor stands still and makes the same noise. So essentially, I have test, okay, touch wood, that gets all the motor parameters without actually turning the motor, which is fantastic. That's where we want it to be. And anyway, have a nice year, all the rest of it, and yeah, good luck. Cheers, bye.